Hello, welcome to another coding session. More Bangalang, more of our low-level explicit compiled procedural language that should make it easier to switch between CPU and GPU execution. I have like a few things in my head that I feel like are going to make the language so much more nicer, and I'm still quite excited about this project, even though we're up to like, I don't know what it, well, this is 84, so this is probably session 85. So, you know, we've been doing it for a while. So before I forget, one of the things I want to do is, I guess I'll call it composable structs, which is where, this is the way that I'm going to do like extending structs, you could say. So you can compose a struct from other structs. And so then effectively they inherit the members of those structs, and then they can be passed polymorphically and stuff like that. But we'll get more into that when we actually do it. I just wanted to put it on the list here before I forget. This one here, unsigned ints, we've taken care of that last time. I do also have this up here, compile time bounds checking. I also changed that to be unsigned. But one gap in all of this, and one thing that I've been, I think I need to get rid of this because it throws a panic, that I've been having trouble with, well, not having trouble with, but just like avoided for a long time. And I put it on one of the thumbnails for one of my videos where I improved the unsigned integers, or maybe it was just when I first added them. And what I put on the thumbnail was something like, you know, my uint, and I give it a type of u8 equals -1, and I crossed out this -1 to say like you can't do that. But actually, if I run the playground, it doesn't complain about this. This is totally fine. So I want to kind of fix this, because that'll also mean, because at the moment our compile time bounds checking, so for something like this where we have, you know, a 3, so that's at compile time we check. Wait, no, this is on the heap, but it's a fixed size array. You know, we know there's 10 elements, so at compile time we can see whether 3 is within the bounds. If I put -3 here, I'm curious what happens. So I think this is the panic out of bounds happening here. Yeah. So it panics, it panics at runtime. Interesting. Because if I take that out, it was, everything was fine, right? Okay, so maybe that is a runtime one. Oh yeah, because this will create a slice. This will create a slice. So it does do it runtime. But maybe as an extra test, we can say like my array, and then we'll go u810, and then we'll say blah is my array -5. So this is just an array, so this should all be compile time. Let's try that. Okay, we get a panic out of bounds, which also, like, this panic is a runtime thing. You know, it's like it's executed all the other text, the other code, and then it's throwing the error. So I'm a little bit surprised by that. I didn't think that would even exist at this point. But let's see what happens. Well, I'm going to make it so we can't put this negative here. That's the idea. So I think I figured out that that would be in, if I go into source, type checking types. I figured out, I think, that the best place to do it is when we upgrade our types. Here it is, upgrade types. Because this is called, I did a bit of searching, and I figured out that anytime that we want to upgrade, an and any number, or an any int. Those are the two sort of like partial types, I kind of call them. They haven't been, so we've figured out that it's some sort of int or some sort of number, and now we're upgrading it to a proper type, you know, like a U8 or a U32, some sort of size, or an I40, I64, because any number could be signed as well. So this is the procedure that does that upgrades that stuff. So I think what I want to do is I'm going to actually make like a special branch here that is specifically for, no, not float, for int and number. So I'll take int and number out of here because we're handling it specially. And in this branch, I'm going to do an extra check. So Jesus, my typing is terrible today. So we're going to do a linear search. I think I put the list here first, and then it's what we're upgrading to, which is the new node type, node dot value, and I think it's underscore first. So this should tell us whether we're upgrading to an unsigned integer. And if we are, why did that not, the fact that that did not indent properly kind of makes me worried. That's probably why. Okay, so we know we're upgrading to an unsigned integer. And the other thing we want to know is maybe put this in an outer loop so we avoid the search if we don't need to actually do that search. So what we're looking for is a negative integer, right? So if the node we are upgrading is a number literal and, man, my typing. Oof. Strings dot, if it has the prefix of, let's see, node dot value has the prefix of the minus sign, you know, that means, well, this should be double equals. That means that we're looking at a negative number literal. So we're looking at negative number literal, and we're upgrading that to an unsigned integer. That's not allowed. So now we need to look for like an error. So I think it's like print position message, something like this. Show an error, and I'm going to say something like no, cannot upgrade negative integer literal, and then we'll put literal to type. So yeah, node.value is integer literal, and then I think it's type name of new type node. Is that right? We passed the node in? Yeah, looks like it. Okay. And then I'm going to return false to say that something went wrong. Now this procedure does not actually return a type at the moment, so we're going to add that. And then for all other cases, we return true because we were successful. And now we look again for where we call that. So upgrade types. This one's never going to trigger because it's never upgrading to an unsigned integer. But I think it's good just to put or return everywhere anyway. I guess that this returns a Boolean already. Yeah. Here we are upgrading to unsigned integers. So, and this is actually indexing. So this is where we're doing this. So now we have that check in here. That was kind of the whole point. But there's a few more places, quite a few places here. Or return. Does this return a bool? Yeah. Or return there, and then. So again, these ones obviously are not upgrading to unsigned integers. But I'm going to put a return, because who knows, maybe we put another check in here later. It's possible. So to cover all those, just better just to put it everywhere. I think there is a way actually that I can make it so that you're not allowed to ignore. Oh, I think this was supposed to go down here. That you're not allowed to ignore a return value, and then, you know, I would have to have or return, and that would prevent me from missing that out sometimes, which would be good. I should probably look up how to do that. I'm pretty sure Odin does that. It might be a nice default, actually. I could add that to my language. So many features to add. Okay, so I think that should be that. So this should complain now, if I try to run it. Yeah, it complains in both places. You can't do that. So I can do this and I can do that. Where's that? Core OS. Okay. So this has a -1 here. I'm just going to cast that to a U64. I did make like Linux syscalls. mmap. Or maybe actually, maybe it should be here. Because all of these are typed, you know, like see this one's pointed to a byte, pointed to 32. I put specific types in, and then I use this danger untyped as a way to cast later. So maybe, which one is it? It's the second to last parameter, which is the file descriptor, I guess. So the file descriptor can be in, oh, but I've put U64 for file descriptors everywhere. Oh, that's right, because I can output JSON now. So there's not too many places. Is it all in that file? It is. So maybe file descriptors should be I64 because -1 counts, I guess, as a special case. I'm not sure if this is the right thing to do, but that's what I'm going to do for now. But syscall is expecting U64s. I think that's that. I don't know if there's anywhere where those are used and it's going to complain now. Nope, that's happy. Okay, great, done. All right, now we're going to move into the next thing, because that was kind of a bit of a cleanup, but we can do that. And I do want to move down to cleanup still, but it's kind of a feature, I guess you could say, what I want to add now, which is for for loops. We've got a few things to fix up for for loops. I want to add this, make index available in ranged fors. So let's close a bunch of these files. So maybe we'll open the grammar actually. For a ranged for statement, ranged for identifier. See if I can remember how to do this. You need to have the slash afterwards. Identifier, and then you can have a comma followed by another identifier. So I've added this part here. So for identifier, and then you can have comma another identifier in. That's our ranged for loop. That's what we've got up here. So I'm adding that you can do this. And I've named this identifier index because that's what that's going to hold. It's going to be an easy way to get at the index. You've probably noticed me doing this in Odin code. Odin has this feature, which I think has been super handy, because without that, then you have to basically fall back to a traditional for loop if you want the index. But if all you want is the index, I think it's really nice just to have this little feature. So I'm going to add that. And I'm also going to add it down here. And I'm just going to put value plus index so that we have some way to test it. So how does that work? Let's go into parsing. I think will be the first step when we're parsing our ranged for loop. That's here. We look for the for keyword. Then we look for the element, which is this. And then after that, I want to check, do we have a peak token? I don't know. Peak token, the type is, if we get a comma after, not declared by AST. Oh, it's tokens. Then we're going to do something very similar in here, but this time we'll call it the index token. Index OK. Like so. 4 must be followed by an integer. It's like expected index identifier in range for loop. Maybe that's a better way of saying it. Update these. Maybe we should update all error messages to be something like this. Element identifier in range for loop must be followed by in. So I'm just going to say expected in keyword. Okay. So now we have this index token. So this is where we added the element. So now we will add the index. So there we go. So now I have an extra node, which is the index. I think that's basically it for parsing. We can optionally do that. Type checking, I'm sure, will be where it's more complicated. It's our ranged for type checking. So basically what happens for a ranged for loop is that in type checking, I take the AST of the ranged for loop, and then I use that to produce AST of a basic for loop, I call it. So just, the traditional for loop. And once I've created that, then I type check that. And then in generation, it's just a basic for loop. You see it because I replaced the node with the basic for loop node. So basically it converts it. It's like, it's just syntactical sugar that actually gets converted to the standard for loop and then type checked. So this is where things are probably going to get complicated. So I say if length is 3, Then we have element expression scope. Which I guess would be element expression scope. And if there's 4 previously, that would have been element, well, this has got 2 nodes, right? The start and the end expression, and then the scope, which is why I refer to this as the start expression. But this has only got a start expression, it doesn't have an end. But the problem is that now we have this optional comma. So doing this check based on the length of the children becomes more problematic because there's 2 variables at play. We could optionally have an end expression. So this one has an end expression. We could also optionally have a comma. And I think the resolution to this is that we need to give our AST a bit more structure. There's a few places actually in the AST where it's very flat like this, and we just use the position of the child to know what it is referring to. And I think it's not the best. So I think what I'm going to do is just introduce like a group type. So these are all the types of nodes we can have in the AST. I'm just going to add like a group one. So we can have a group, which is just, yeah, a super generic thing for organizing the AST. So this node, we add the element node, possibly the index node, start node, possibly the end node, and the scope node. And I'm going to say that this here, actually, that was the idea I had, is to say that this has a single node, which is a node of type range, and that has 2 children. One is the start expression and one is the end expression. So instead of this just being 2 nodes floating in our for loop, it gets sort of consolidated into a range node. So it's more explicit what's going on. I still want the group, but I think we also want the range. And that's what we want to do here. So if I say range node is make a node with type range, and well, actually it depends, doesn't it? Because if we just have a single expression, then it's not a range. You know, and in this case it's not a range, in this case it is. So it could be a range, it could be not. We don't know yet, but if we see this period, this dot dot, then we know we're in a range. So I think this is where we need to say, well, first we consume the dot dot, we create our range node, create our end expression node. I guess I could do this actually. So we pass the end expression, then we say, okay, let's add the start and end expressions to our range and add our range to the parent. So, and this here is when we add the start directly, and that would be if we're not in a range. Right? Yeah, so if we do go into a range, then we create this range structure. Otherwise, we just add the expression directly. So now we know if we come across a range node, we're dealing with range. And the rest, do I want to group? You know, I had that group idea. Do I want to group these? There's some other places that I want to group, but I think I do want to group these. I think my idea is that, you know, when we have a comma-separated list of things, that's kind of a group. There's some places where that's not really needed. You know, like a call. A call is just this. So there's no point in wrapping these two things in a group because they're the only two things. It's like it's a redundant node. But in some cases, and also like this, it's the same thing. But in some places it does make sense. Like a procedure definition. Like here we have the name of the procedure, then we can have a combo separated list. So turn this into a group. Anyway, the conclusion is that we will make a group here. And there will be a group regardless. It might only have one thing in it, but that's okay. So I'm going to call it the values, because it's sort of like the values in the for loop. These two are the values. So that's going to be a make node where type is, what did I say, group. And I'll give it a value as well. And maybe it would help with debugging. You know, I'll call it the values node so we know, because group is very generic. So this gives a bit more context. But it's not actually going to be used by the compiler. It's just, you know, if we're inspecting, then we can see more clearly what's going on. So the element node gets added to the values. The index node gets added to the values. And then the values gets added to the parent. So now we always have, in a ranged for loop, we always have three children, I think. We have the values. I'm going to move that up here, actually. We have the values node, which contains two things. We have either the expression node or the range node, and then we have the scope node. So it has three children, always has three. So then when we get to type checking, we can break out our nodes straight away. So we can say our values node. Did I get this right? I get a bit confused because there's sort of like different ways. Yeah, this is how I do it in my language. And it's just a convention, really. It doesn't really matter, but just trying to be consistent. So values node is the first one. The second one is it's kind of the expression node. Well, I guess it depends which branch we go into, but no, I don't think it matters that much. And then the third node is the scope node. I'm pretty sure that's all it is, right? Node.children, we had the range or the expression, the scope, and the values. Yeah. So that should be right. So then if expression node.type is if we're talking about a range, I think this is actually not the code that deals with a range. I think it's this code. Yes, the start and end. So let's put that up here, and I accidentally grabbed the else. Whoops. Oh my God, what did I do? Oh, God. I always press that key on by accident. That's quite annoying. There we go. Okay, so now we're dealing with the range. We know it's a range. So the element node we know is this one. That's also kind of common. The element node is always the first of the value nodes. And then the index node is if the values has more than one child, then the second child is the index node. And then here's the start and end expression node, which are parts of the expression node. Yeah, okay. We also have an expression node here. I'm going to call this the basic expression node because it's part of the basic for loop. Maybe that's a good thing to do, actually make these all basic prefixed. So it's very clear. Okay. That's that. So we're not actually using this index node yet. And maybe we won't yet. We'll just make sure that the structure is getting like parsed and type checked and everything correctly, and then we'll start to use that index. So this should, now it's looking at the structure correctly, I think. It's looking at the values and the expression node correctly, I think. Yeah. Okay. So this one, the start expression node is it's the first one, child of that. So that should be 0, 1 actually. Yeah. And this is of course, the basic index node. The length type node, I feel like we have like a kind of a global for that. Let's just do all these. This is updating the element. So updating this. No, I think it's updating this. If we're in this kind of loop, then that updates that at the end of the loop. We inject it at the end of the loop. Yeah, element assignment. Scope node. Yeah, I guess the scope node just gets passed along. Nothing gets done to it really. Well, this gets injected into it, but okay. So I think, and here we're referring to index node, so that should be basic index node, I think, because we changed the name of that. Yeah, length type node. Ranged for, it's in the utilities here. But this is this is generation, and this is type checking. But I think actually, like this is the U64 type node. And what we can actually do is just go, we know it lives on the context, well, on the program identifiers. So we can just go like that. We don't have to make a new one. Okay. All right, I think I'm pretty happy that that's using the structure correctly. Then the last thing is we need to go to generation and just make sure that when we generate our basic for, that it's also looking at the structure correctly. So here we're a bit, so what is the new structure? Well, it's just a basic for loop, isn't it? I don't think it's changed. I think it's the same. Oh, scope must begin with bracket. Line 6. Interesting. Scope must begin with bracket. So it looks like it's trying to parse this, but it's finding something else. So maybe it's trying to do it too early, maybe. Scope must begin with, yeah, we're parsing. So we're parsing a scope. So let's go to arrange for parsing. So it looks like we've got something wrong here. Oh, well, one thing that comes to mind is that we need to consume the comma. Like that. That could have been the issue. Index has not been declared. Oh, we also get an index out of range though, here. That's interesting. Like, I understand that index has not been declared, but the fact that this is giving an error. Expression node should be an expression node with a child. So this is when we're talking about the one it's not a range. It's just this, and it can't find value. We have this values node. We've added element node to it. And yeah, and then it hasn't been played with. We're just grabbing the second child. So what happens if we put a debug here? Expression node is an identifier. Foo. Yep, that makes sense. That's this one, identifier foo, that's the expression. So in this case, yeah, in this case we don't need to get a child of it. That was only here because in this case it's a range, so it has two children. But here we just want to get this directly. And I'm just going to call it expression node. It doesn't need, there's no start and end, you know, it's just an expression node. But that's also called expression. Oh yeah, but that's the node we're talking about. That's the node we're talking about. Okay. Okay, so that is not an issue now. But we do get these has not been declared. And index, like, it totally makes sense because we haven't actually done anything with the index yet. But we are trying to use it here, but we've done nothing to like present this. I think I might start with this one. I think this one's going to be a bit easier because we already do have an index. If we go to not the ranged one, so it starts here. This is the non-ranged one. See, we already create this special index variable to hold the index. So we are keeping track of the index, and that's how, you know, if I grab this, so we assign a 0 to it in the beginning. We compare it against the length of the thing that we're iterating through. Each iteration of the loop, we increment it. And this should be basic index node also. So, because at the end, at the bottom of the loop, we use it to assign a new value. I don't think we need to put type none there, because this is element node. Oh no, we're injecting it at the top. So this is at the top of the loop. We say, okay, the element is equal to this index of the expression. You know, so a certain index of foo is the expression. So we do have this index that we're passing around, but it's just not available. So what I might do is just say basic index node is this index node, right, that we passed in. So this is an identifier. In our case, it's called index, but you could give it any name. So now in this loop, we're saying we'll use that, basically use that name. Instead of making up some hidden name, the square brackets effectively make it hidden. Just use that name that we got given. And if we weren't given one, i.e. index node is nil, then sure, let's just do what we were doing before. So now it should be available. If we run that. So index has not been declared on line 7. So we haven't fixed that one yet, but we did fix this one. And we get types are not compatible, F32, FU64 on line 11. So value is part of a vec4. So this is an F32. And the index is probably a U64. Yeah, this is where we declare it as a U64. So that makes total sense. You know, they're different types. So if I just cast that to an F32, then it should be happy. Okay, so this seems happy. This is not happy because we haven't figured this out yet. I think this one gets a bit trickier because now effectively, so every iteration of the loop in here, we're already using, you know, in a traditional for loop. So the traditional for loop of this would be for, value which is an I64 starting at 0, value is less than 10, value plus equals 1, do that. Right? That's what we're generating right now. And the problem is that index is nowhere to be found is not declared here. So effectively what we need to do is something kind of like index U64 equals 0. And then at the bottom of the scope, we need to do index plus equals 1. And we're going to do this in a way that, like, once the for loop finishes, then index gets, you know, it's not still in scope. It's not going to interfere. You know, this is not going to complain that index already exists. So this is effectively what we want to do. So somehow we need to put this up here. We do kind of do that already for generation. If we go to the generation for a basic for, what we do is, so this is the label that goes in the assembly that's like the top of the loop. So each iteration of the loop, it'll loop back up to here. But before that, we generate this assignment, which is this assignment here, because it needs to happen before the loop, basically. We don't want it to assign every iteration of the loop. We just do it at the top. So we kind of want, so it's kind of like this. You could sort of think of that being there as well. And both of these values we want to get cut out at the end. And the way we do that is just by having, you know, this, I think we have, it's in the basic for loop, I think. Yeah, see, we create a copy of the context straight away. So then any variables that we create through these assignments and stuff, they only exist in this copy of the assignment, this local copy. So then when we leave the for loop and we go back to this context, they don't exist anymore. That's how we take care of that. So because we have this thing already that happens before, and at the moment it can only be a single assignment, we did just introduce that concept of groups, right? So I think I'm going to take that concept and abuse it a little bit straight away, right out of the gate. So that, because I think we can do like generate statements. Yeah, which just loops through a set of statements and generates them. Very simple. So then if this were to be a group, that's expecting an array. It's expecting a slice. Yeah, so then it'll generate, then we could do multiple assignments, like we were saying we want to do, and it should work. So for that, then we need to say, okay, a basic for loop has a group. I call it the pre-node. I call this the pre. This is the expression, and this is the post. Pre and post, because it goes before and after the expression. So this pre, we want that to be able to hold multiple statements, so it can hold both of these in a basic for loop. So let's start from the beginning, so that all basic for loops have this pattern, and then it makes it easier. So here's our pre declaration. It's optional, but if we do find it, then instead of just adding it straight up, we're going to say here's a pre-node, which is a group. Again, for debugging purposes, let's call it pre. And then we add our pre-declaration to that pre, and we add our pre to the parent. So it's just got that extra level of indirection, which is like, in most cases, pointless. I feel like this is not the best way to do this. Like I said, it's a bit of an abuse of this new group feature. But it should work. So parsing a basic for, so parsing a ranged for should also, well, it doesn't have a concept of a pre. It's when we do type checking, we convert it. Then we need to do this pre business. So down, let's do this bottom one because this was the easier one. So the pre is this. Here's the basic pre-declaration. So let's do basic pre-node is, again, we make a group node called pre. And here we say, okay, basic pre-node gets that, and then the basic for loop gets the pre. So basically, again, this is the assignment that goes at the start, and we've wrapped it. Then we go to generation. And here, maybe we can we improve this whole indexy business? Let's give it a go. So the pre-node, where it depends. So if the first child is a group, then that's the pre-node. Otherwise, there is no pre-node. The expression node depends whether there was a pre-node or not. So if there was a pre-node, then we want index 1. Let's go this way around. And I can do 0, 1. That's nice. So if there wasn't a pre-node, then the first one is the expression. Otherwise, it's the second one. And then the last thing is the post node, which maybe for consistency, I call it a post assignment node here. So let's call it the post assignment node. That depends. I think we need to save this actually. expression node index like that. So if the length of children is greater than that plus 1, which means there is another node after the expression node, then we grab it. Otherwise there is none, because it's also optional. It might not be there. So those are our nodes. So I think we can get rid of this whole business, and then we can be a bit more explicit. We can say, you know, if there was a prenode, then we generate all its children. Don't need that anymore. So we can do like, I think we can just do. What I like about my language and not about Odin is you can't do this. See, it complains. So annoying. So if this gets too long, then it's just like ugly and I don't want to use it, then I use fallback to braces, which I think is not so nice. Okay, so this is the expression node we're talking about here. Get rid of this. Statement node, I think that's talking about the... Oh, there's also a scope node. Yeah, actually something I also had in my head, because we need to, I think it's nice to give it a bit more structure. And I said earlier that I kind of think of anywhere where there's comma separated stuff as a group. So I'm thinking this here is a group. Let's turn that into a group. So this is the pre. So before that, let's say, I'm going to call it the flow node, because it's sort of, I don't know if that makes sense actually. But these are kind of the statements that determine the flow control in a way. Good enough. So I'll call that a, whoops, group, and we'll call that flow. So this would actually get added, the pre-node would get added to the flow node, expression node would get added to the flow node, and the post node would get added to the flow node. And then the flow node would get added to the parent. Okay. And in here we need to do that also. So we'll make a basic flow node. Oh, that seems like a problem. So let's go basic flow node, basic flow node, basic flow node. This is going within the scope, that's fine. And the flow node is getting added to the for node along with the scope. So now, a basic for node has two children, one child in the AST. One child is all of this combined together. The other node is this. And then within this, we have a few children, which we break out to get these things. We still need to do this, this ranged for loop up here. We need to adjust the structure of that, but hopefully that works for this bottom one. So now here, actually the pre-node is, no, this is the flow node. This is the first child. And now we're talking about that. Oh, I don't like how that kind of highlights all of the, is that new? I want to know just where all the instances of this variable are. I think everything else is like just a suffix. Oh, this one here is using node. And I think this is actually the post. Yeah, this is the scope. So scope node is 1. So actually down here generates, when we generate the scope, it's the scope node. Makes sense. And if pre-node is not equal nil, we do the pre stuff, and this is the post stuff. So if post node is not nil, then we do the post node. I call it post assignment node. Okay. I think that's it. We just broke that out and used flow node for all that stuff. Yeah, I think that's okay. I don't know, since we haven't fixed the other version, I wouldn't be surprised if this just like fell over. Okay, it's saying 7 and 10. I mean, I'm sure it's not happy about this because this was just an example where I was kind of messing about. Index on line 10 has not been declared. Okay. That could be because of the type checking in here. The basic flow node. Do we create this correctly? Basic flow node holds the basic pre node. Which only has one thing in it. But that is the index. I feel like that should be fine. Basic flow node gets added to the for node. Scope node gets added to the for node. Pre node gets added to the flow node. I mean, I think that's all right. I think. Have I not done anything with the type checking of a basic for? Oh, yes, we need to change this. Okay, so we need to do something probably based similar to here. Maybe we'll grab all the nodes in the same way. Because we can rely on parsing to make sure that the basic structure is right. So here we want to type check statements. Yeah, this makes sense why this was not working. So if the pre-node is not null, pre-node dot children slice. Type check the expression, so that's the expression node. Get rid of that, get rid of that. This is the scope node. And I hate how it does that. If the post assignment node is not null, then we type check that. It's quite short really, isn't it? It's basically just parsing out all the nodes and then performing type checking on all of them, which is delegating to other procedures. Okay, so we're getting there. We're getting there. So this seemed to have type checked fine. This still doesn't know about the index, but that's okay because we haven't really done much work for that. I feel like our parsing is all good. So we need to go up to this top loop and we need to make sure that this is creating the correct structure. So we're going to need these two things. And our flow node is going to contain, no, this is going to be in our pre node. Which then is within the flow node. Then these two are within the flow node. And then the flow node goes in there, into the main node. So I think that's kind of got our flow pre-structure correct. So I think we have a correct structure now. But obviously we still haven't declared the index. But now that we've made this pre a group, this is where in the pre we did have an assignment of our element. This is the initialization of our element. So then I think if we have an index, because we don't always have an index, we do something quite similar, I guess. Just plug this in. Basic I'm going to say pre-index node. Like so. And I guess it's similar to down here, actually, when we create our index node. Actually, I think it's basically this. I'm just going to take this and then just do a replace in that selection. So our basic index node, I think, is just our index node. So that's getting the identifier, basically, and we're saying it's U64, which we assigned to 0. Great. And then we've got our scope here, and I think kind of like we did here, where here we injected it at the top. Oh, interesting. Because we need it to be, so this is the continue. This is, it needs to be here. So it needs to be part of the post. I think the post needs to be a group as well. Jeez, it's getting complicated. Because if we do a continue, we still want the index to get incremented, right? That would be a problem if it didn't. So I'm going to call this just the post node. No, slice of the children. Okay. So I think we do actually need to go back to parse. Let's start from parsing. If we're parsing a basic 4, this is the post node. So this is where we need to do something like this. Yeah. So this is the post node. We'll just make a group called post. We'll add the post assignment node to it, and then we add the post node to the flow node. Okay, so we've wrapped this now into a post node. Where we're parsing a 4. Parsing the ranged 4 does not have that concept. Type checking the basic 4. We need to do type check statements, which is the children of the post node. We also already did that here. We can generate multiple statements. So that's those two done. It's just this conversion code that we need to fix up. So this one here is actually getting injected at the start, and that's fine. This is the post. So I think we need to do basic post node. So here we need to add that to the post node, and then add the post node to the flow node. So now that is wrapped. Okay. And now we're going to go up here to these nodes. This is so much manual like node manipulation, which I don't really like, because then if we decide to change our structure, then we have to change all this manual node. I would kind of like, it does get difficult, but in some places it could be nice if we could just take some source code and just like, you know, in here, write a little bit of source code and then just parse that into AST and then go from there. I think that could be nice, but let's not worry about that right now. Right, so up here, we need to do the same thing. So this is the post node, which is a group called post. Like so. So now that is wrapped in the post node. Now we can add a second thing here that happens after. So here we're incrementing the value because it's this value between 0 and 10. So we increment that. Currently that will be exactly the same as the index, but this could be like 5, you know, and then, so this would be 5, this would be 0. So we need to maintain them different separately. But it's just another increment. Where is it? Where the hell is it? Type checking range 4. It's just another increment, which should be kind of like this increment. This post. Isn't that what I put here? No, it's a little bit different. This is the initial assignment. So again, if we have an index node, then then we can go basic post index node, which I guess takes the index node. So that's the identifier, flux equals 1. So we add that to our afterwards stuff. Okay, run that. I64 and U64 not compatible. So these I have casted to I64, so these are I64s. But index is a U64, so let's just make that U64 also maybe. Okay, we got some output. So here value and index are both 0. 0 plus 0 is 0. Here they become 1. 1 and 1 is 2. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, because it goes up to 9. That seems correct to me. It's effectively doubling all the numbers. So I'm pretty happy with that. Here we have 2, 4, 6, 8, and the indexes will be 0, 1, 2, 3. So it should be 2, 5, 8, 11. 2, 5, 8, 11. All right. That's really cool. Yeah, I'm really happy with that. Now we've got this. This is such a nice feature. I really love using it in Odin, so I'm very happy to have it in our language. I think I'm going to leave it at that for now. This is another one for range-based force. We could have a pointer. So that would only apply to this version, where the idea is you could go like that, and it would give you a pointer. Because right now it's giving you a copy of the element. But here it should give you a pointer to the element so then you can manipulate it in place. That's the idea. I mean, if this was an array of pointers, then obviously you would get a pointer here and that would work just fine. Then you would be manipulating the object in place. But if this was an array of objects, like it is here, 2, 4, 6, 8, array of values, I should say, then this will be a copy of 2. Whereas this would be a pointer to 2, and you could change the value in foo. That's the other feature I want to put for loops. Get rid of that. And then the other thing is not requiring casts. Because, well, I mean, what happens if we go like this? Actually, could not determine type. Yeah, so it should just like auto upgrade. I would imagine it should auto upgrade to an I64. I64 would be the simplest. I mean, you could potentially detect, well, I mean, these are just arbitrary expressions, right? No, but if you have to auto upgrade, that means that nowhere in the expression has it determined what the type is. So I guess it's when we're type checking. Let's have a quick look, because maybe we can do this. That's when we're type checking range-based for. So actually it would be, we don't actually do any type checking in here, we just convert it. And when we convert it, so these are the two expressions, 0 and 10. So start expression goes here. So that's got type none. I wonder if I could put any int. I guess it would need to be, for it to be a range, it needs to be something you can do plus equals 1 on, right? I think it could be any number. And then when the expression gets type checked, it should get auto upgraded. I believe to an I64. What about the end expression? End expression, it compares the element to that end expression. So if element has a type, yeah, which it should have gotten upgraded to a type, then this should, would that work? Is that all that needs to be happened? Could not determine type of value. Any number equals, so we've got the start expression node, which does not have any type information. But it's an integer literal. Yeah, I guess it doesn't. I wonder if I also put, maybe if I put none here and any number there. So that's child 1. No, child 2. Child 1 is the equals. So child 2, the start expression, if I give that a type node, could it already have a type node? Am I messing with stuff? I don't understand that well enough right now, I think. I feel like it could have a type node. What I'm going to do is oopsie daisy, I made an issue. I have a problem. If that ever is not nil, then we shouldn't just put any number. Then we should do something. I mean, basically, maybe we just need to, it's as simple as saying, you know, if it's not nil, then give it any number. Let's see what happens. Could not determine type of value. It still doesn't know what type to give it. So it's an assignment, initially has no type. This has an any number type. So any number and none, neither of those provide enough information. But any number, if we go into type checking of a right-hand side expression, the coerced type node, like when we do this upgrade types, the new type node is the coerced type node, and the coerced type node, yeah, if one of them is none, then it grabs the other one. So in this case, the left-hand side and the right-hand side, expected type is left-hand side, right-hand side. So this is none, this is any number. So this should be any number. And if it's not, no, so then we're upgrading to any number. Okay. So then it makes me think, like, because down here, if we come across any number, this is what we do. We upgrade it to I64. So I'm starting to think maybe we should have this up here as well. See, and then the else is to go to the coerced type node. So maybe we just need the same pattern. Let's have a look at this. So the coerced type node could be null, apparently, in which case we don't want to upgrade to null. And we only need to do it once to the node. So I think this is it. So like, if we got to this point and we came across any number, then we upgrade to I64. Okay, this is more, segmentation fault. That is concerning. Let me just see what's going on here. Oh, because it could be null. That's right. I was just saying that it could be null. So we can't be comparing it. So it's actually like, if it's not null, then we do this pattern. Right, so that looks exactly like this, except we're only doing it for one node. And we don't do it if it's null. So then if we run that again, okay. Exit code 1 is expected because there was an error in type checking, but there was no crash. Now I kind of expected this because this is getting upgraded to U64. No, this is getting upgraded to an I64, but this is a U64. So that means we don't need, so I can just go, no, I64 index, and it should work. Yeah, 02468. Cool, so we don't need that cast there. That looks so much nicer. So we have index, we don't have the cast. The range-based for loops are looking pretty good. There's just that one other feature, the pointer part that I want to do. So we can take that out too. And that was just a little 10-minute thing. And I'm like, I haven't actually, I know I've been putting videos out once a week, but I haven't been working on this much recently. So it's not fresh in my mind, but I feel like this is fine. I don't see any issue with this. My head, like, in my head, I don't really understand all the cases and everything that leads to this, but I don't see any problem with this, especially since down in this part of expression handling, it does the same thing. I think previously I just thought that this was not necessary, but now it is because I have created this situation. The only reason we need a type node here is because that's how type checking understands that it's a declaration. This assignment is a declaration because the left-hand side has a type, even if the type is none. When the type is none, that's kind of like this. Well, maybe this is better. So this is an assignment. The left-hand side has a colon, and then it doesn't explicitly say a type. I could do this. This would be the same, right? That should run fine. That's explicitly saying that the bar is a my_enum. It's of type my_enum. But I can omit that. But because there's still a colon, it will add this type none, which then in type checking is used to say like, oh, this was I'm declaring something new. So that's why we need to put that here. And then on the right-hand side, we put any number because we're like, oh, I don't know. And this didn't trip, but let's leave it there. I'll put a little to do because maybe at a later point when I'm feeling more like I know what I'm doing, I can check whether that's actually necessary or what the proper thing is to do with that. But right now I don't really understand properly. Okay, I'm actually really happy with that. I think these for loops, they look really nice. That's basically how I want them. The only downside is this. I mean, you could... No, I don't think it's good to infer the type there and use it up there. So the only thing that... no, you couldn't do it there, but here... You couldn't do it here because there's nothing to point at. These are just ephemeral numbers. Cool. All right. Thanks for stopping by. Have a good one. Ciao for now.